Hello and welcome to LFI Educates. Today we are going to discuss about circular motion, or we call it as uniform circular motion. Uniform circular motion. Circular motion, you already know, when a body goes around a circular path, then the motion of the body we call it as circular motion. The body is traveling in a circular path. But the word uniform, when it comes, then you have to take, if a body covers equal distances in equal intervals of time along a circular path, then that body is said to be in uniform circular motion. Now, while studying uniform circular motion, some terms you'll have to know. Suppose the body is here at point A, then its velocity, your linear velocity, if I say they try to fly over tangentially, the velocity will be tangential to the radius vector. Now this body, when it travels from, suppose say A to B, if it travels from A to B, then these two will remain the same, the radius vector will remain the same, velocity also will remain the same, thus represented as V dash. Now during the time the body travels from A to B, suppose it started at the 0 hour, T naught, T is equal to 0 to T is equal to T, suppose it took time T to reach from A to B. And how much the angle is described here, we can take it as d theta in terms of small angle, or simply you can take it as theta as well. This angle that is describes while traveling from A to B, we call it as angular displacement. We call it as angular displacement, and we write it as theta. The angle described at the center of the circular path when a body moves from one point to another point in a circular motion, we call it as angular displacement. Then the next term that we have to know is about angular velocity. We write it as omega. Angular velocity is nothing but it's simply angular displacement per unit time. Angular velocity is angular displacement per unit time, like your linear velocity. Linear velocity, we write it as V, and it is displacement, we wrote it as S before, position with respect to time. Displacement with respect to time gives us linear velocity. And here also displacement, but the displacement will be angular displacement for angular velocity. Likewise, when we discuss about angular acceleration, if you say angular acceleration, it is angular velocity with respect to time. Like your linear acceleration, acceleration is velocity with respect to time. Like here angular acceleration, then angular velocity with respect to time will give you angular acceleration. So let us see a relation between these two, angular velocity, this one angular velocity and linear velocity. There exists a relation between them. Let us do and see. Relation between V, we know that they are in terms of vectors, or it's a vector quantity, and angular velocity. Omega. While deriving, you can derive it in terms of scalar, and we know that a vector can be represented in scalar as well, but a scalar cannot be represented in vector form. So deriving time you can use simple scalar form, and then at last in vector form you can write down. It's up to your convenience, you can do it. Now to get the relation between linear velocity and angular velocity, you can take the example like this. A body, suppose, is starting at t equal to 0 from point A and is moving along a circular path at point B. Suppose at t equal to 0, the position of the body is at A and it is undergoing uniform circular motion. Let t be the time the body reaches at B. Here V is the linear velocity and theta is the angular displacement. Then using your trigonometry formula, angle equal arc length divided by radius. Angle is equal to arc length. Your arc length here is AB divided by the radius. Angle is theta here. Arc length AB divided by radius we are taking it as r. So AB is equal to r theta, dividing both sides by t, we get AB divided by t is equal to r theta divided by t. Here you can see that AB is the actual path traveled by the body, distance divided by time. Distance by time is our linear velocity, or displacement by time is linear velocity v. First we will write down in scalar form only r, and this is angular displacement per unit time is angular velocity omega. This is our relation, v is equal to r omega. In vector form you can write it as v is equal to r omega as well. So this is the relation that exists between a linear velocity and angular velocity. So you have to keep by heart v is equal to r omega. V is equal to r omega. Expression for centripetal acceleration, we write it as AC. Centripetal acceleration means angular acceleration, the same thing. Angular acceleration is the angular velocity per unit time. That is your angular acceleration or centripetal acceleration. Here, see the diagram with how to draw and how to get the expression. Suppose this is the circular path, like the previous one that we have taken. This is the center. The body is at A, point A, at time instant t equal to 0. The body is undergoing uniform circular motion. Here let me take it as r, radius vector as r. The linear velocity, which will be tangential at this point, let us take it as v. Now when the body has moved at this point B, the velocity will take it as v dash, but you should remember that v and v dash both are equal. They are traveling with same velocity, just at 2 points we are taking, that's why I am writing it as v dash. Here the position vector you can take it as, let it be r dash. Here also the values are equal. In this case we have to resolve into its resolution of vectors. We have to do this velocity vector. I am bringing it here parallel to it, then it will look like this. This is your velocity vector, and this vector if I bring parallelly like this, then it will come here, let it be v dash, like this. Let this point be O. Here also I have taken O, here also I have taken O. This is velocity vector. In terms of vector, you represent it in the diagram. Then this closing side, this way it will come. If you use triangle law of vector addition, then this will be representing the change in velocity, final velocity minus initial velocity delta v. It will be pointing at the center of the circular path. Centrifugal acceleration always points at the center of the circular path. And here r dash, this is the final position. These are in terms of position vector. Suppose r dash final position, r is the initial position, this is change in position, we write this delta r, and the arrowhead will be pointing which side. You can come to know it is going this way, then this will give us the resultant. Final position will give us the resultant. The body is moving from A to B, so displacement is from A to B. The arrow will be upside. So in this case, if you look carefully, these two triangles that I have taken, OAB, and let me write here also some letters. Let it be O dash, let it be A dash, and let it be B dash. For OA, for OA this side I have taken as O dash, A dash. These two triangles will be similar if you look carefully, because V and B dash, their velocities are same, equal. R and R dash, their velocities are equal. The angle between the two position vector here, if I take it as theta, then here also angle between the two velocity vector will be theta. So these two triangles, if I take like this, triangle OAB is similar to triangle A dash, O dash, B dash, or O dash, A dash, B dash. In this case, if the triangles are similar, then you can write down like this, the ratio of their sides. If I take here A dash, B dash, then I'll take here AB. A dash, B dash by AB is equal to O dash A divided by OA. O dash A divided by OA, that is equal to O dash B dash divided by OB, but the ratio will remain the same, V by R and B dash by R dash. The values, these two are equal, these two are also equal, so value will remain the same. So the dash part I am not taking. Then it will come out like this. What is A dash B dash? Then write delta V. I am doing in scalar. In scalar form I am writing, divided by delta R is equal to A dash O. A dash O. Sorry, A dash O dash it should be. A dash O dash is equal to V divided by OA. OA I am writing in scalar form, this is R. So if you cross multiply, it will be like this, R delta V is equal to V delta R. So if you divide it with respect to time, dividing both sides by time t, initial starting time we took it as t equal to 0, final time let it be t. Then you get like this, R delta V by t is equal to v delta r by t. And you know that change in velocity with respect to time is your acceleration. This will give you your centripetal acceleration. This is equal to v. Change in position with respect to time is your displacement. Change in position r, radius vector. Change in position with respect to time will give you your position with respect to time. It is velocity. So centripetal acceleration is equal to v squared divided by r. This is your final expression. This is in terms of linear velocity. In terms of linear velocity. And if you want to write in terms of angular velocity omega, then AC is equal to V. As you know, linear velocity is r omega, and as it is square, you can put square divided by r. It will become r square omega square by r. One r, if you cancel it, r omega square, you will get it. This will be in terms of angular velocity. In terms of angular velocity. So in terms of linear velocity, AC, the centripetal acceleration is linear velocity squared divided by the distance r, distance from the center, and angular acceleration or centripetal acceleration in terms of angular velocity will be r omega square. Both are vector quantities. Velocity, acceleration is vector, velocity is vector. Here also acceleration is vector, velocity is, angular velocity is also vector. If you write in vector form, this one in vector form, you can write it as AC with arrowhead, v square with arrowhead divided by r. And this one in terms of vector, if you write in vector form, you can write it as AC is equal to r omega square. So this way you can get the expression for centripetal acceleration. Writings as we have written in case of relation between linear velocity and angular velocity, you can start writing like this. Let t equal to 0, a body start from position A. After reaching time t, it has moved to position B with a uniform velocity. Let the linear velocity be v, angular displacement be theta. Then resolving the vectors v and v dash into their components. How to resolve it? You bring the objects parallel, the velocity parallel. A, it is velocity vector v, bring parallel like this, and this v dash also bring parallelly like this, and join it. Then the change in velocity, final velocity minus initial velocity, you can represent this way. It will be pointing at the center of the circular path. Centripetal acceleration always points towards the center of the circular path. Now you may be thinking that why these two angles are equal. If you want to know, it is like this. I'll show you. To understand this, why these two triangles are similar, or in other words, why these angles are theta each. You look carefully. I'll do it here and show you. This v dash, if I produce it back side, then it will come like this. And v, if I produce this way, it will go like this. So this is v and this is v dash. This is v, velocity vector. The angle between them must come out as theta, because here also between v and v dash, we took it as theta. How do we get geometrically? You can see. First of all, OA, let this point be K. OAKB is quadrilateral. In quadrilateral, OAKB, here you can see angle B is 90 degree because this is radius and this is tangent, so it will be perpendicular. Angle A is also 90 degree, you can see clearly, here it is 90 degree, and this angle is theta. The sum of all the four angles in a quadrilateral is 360. So angle O plus angle A plus angle B plus angle BKA is equal to 360 degree. And if I put the values here, angle O is theta, angle A is 90 degree, angle B is 90 degree, angle BKA is equal to 360 degree. So if I take this angle BKA, you can see this is 360, 180, if I bring this side minus 180, plus theta will become minus theta. So you will get here 180 minus theta. So BKA, angle BKA is 180 minus theta. So this, for time being, I will remove this curve. This is 180 minus theta. So this angle BKV, suppose here, or say in case of V I am writing M, BKM is equal to, total from here to here is 180 minus this angle BKA. So angle BKM is equal to 180 minus angle BKA. This is 180 minus BKA, we found out here. This is 180 minus theta. So this is 180 minus 180 plus theta. These two will get cancelled, so you get here theta. So BKM. So BKM, we are writing it as theta. That means the angle between V dash and V is theta. The same angle will get it here. That's why we are writing here theta. And the other thing that you have to know is why these two triangles are similar. Because V by R is equal to V dash by R dash. If V value is 10 meter per second, R is 5, then here also V and V dash are equal, so it will be 10. And R and R dash are equal, so it will be 5. So the ratio of their sides are in proportion. These two sides, the ratio are in proportion. And the included angle, the theta, here also angle is theta. So by SAS similarity criteria, the two triangles are similar. That is the reason why we used to take this O dash, A dash, B dash and OAB as similar triangles. So starting we did with this, they are similar. Then ratio we took and got the expression. In exam you don't have to show this one, this part you don't have to show. It is understood that these two triangles will be similar, OAB and O dash, B dash. But for your knowledge, if you know and keep like this, it is good that why you are taking exactly we know why it is like this, like this, like that. So you come to know. Let us see some more terms related to circular motion. So you need to know the terms related to circular motion. Frequency, we write it as simple F, or more popularly we used to write it as nu. We pronounce it as nu. Frequency is the number of revolutions completed in 1 second, that we call it as frequency. When a body is in circular motion, how many times it can complete the circular motion in 1 second, that we call it as frequency. And frequency, the SI unit of frequency is hertz. We write in short as Hz. Hz. It represents the number of revolutions completed in 1 second, that we call it as frequency. The next thing that we have to know is about time period. We write it as capital T. The time taken by the object to go one round in a circular path, we call it as time period. How long it takes to complete one revolution. we call it as time period. Mathematically, time period, the SI unit of time period is second. SI unit of time period is equal to is second. Simply we write it as S. Time period mathematically can be written as the reciprocal of frequency, or 1 by nu. This is the reciprocal of frequency, and frequency is the time inversely proportional to time period. Time period is inversely proportional to frequency. Then the next thing, the relationship between time period and, this is the relationship between time period and frequency. There exists a relationship between angular velocity and time period. Relation between angular velocity frequency and time period. The relation is that angular velocity is equal to angular displacement per unit time. Now when a body goes one round in a circular path, suppose from here it started, then it is moving in a circular path and it has reached at point A, it describes a complete angle of, suppose this is the starting point, it describes a complete angle of 2 pi. 2 times 180, that is 360. So the angle described will be 2 pi. And time period for complete rotation we write it as t. So this is the relation, omega is equal to 2 pi by t. This is the relation between angular velocity and time period. Angular velocity and time period. Now again we know that angular velocity is equal to 2 pi by t is equal to reciprocal of frequency 1 by nu, or we write it as f, whatever you write. Angular velocity omega is equal to 2 pi nu, or 2 pi f. So this is the relation between angular velocity and frequency. Angular velocity and frequency. So these are the things that you have to keep in mind about frequency, time period, angular velocity and time period, angular velocity and frequency, how they are related. Then relationship between linear velocity and angular velocity that we have derived already. Then we have got the expression for centripetal acceleration, that is your angular acceleration. So these are the things you need to remember. Now let us see about one more term, that is centripetal force. Centripetal acceleration you have derived. Centripetal acceleration AC is equal to v square by r. So centripetal force we write it as Fc. It is defined as centripetal acceleration per unit. Force is equal to mass into acceleration. Acceleration is centripetal acceleration. So mass into centripetal acceleration is v square by r. So centripetal force is expressed as mv square divided by r. This is the relation that you have to know. This is centripetal force. In vector form, if you write Fc is equal to mv square, this is vector, divided by r. Like this also you can represent in vector form centripetal force. Now when a body is moving in a circular path, where the force exists, suppose this is the position of the body, centripetal force and centripetal acceleration will be directing towards the center of the circular path. Center of the circular path. AC also will point this side from the body towards the center. If the body is here, it will point towards the center this side. So centripetal force and centripetal acceleration both will point towards the center of the circular path. These are the terms that we'll be using. Let us do one simple numerical and see. Let us see this question. A body of mass 10 kg. Here you have mass is equal to 10 kg. Revolves in a circular path of diameter 0.4 meter. Diameter you change it into radius. 0.4 divided by 2 will give you 0.2 meter. Making 1000 revolutions per minute. So number of revolution per second equal to frequency. So here you can find out frequency nu is equal to 1000 revolution per minute. 1 minute. So it will become 1000 divided by 60 second. So this one will write it as 2 3s are 6, 2 5s are 10, 0. It is 50 by 3 hertz. This is your frequency. Calculate its linear velocity. Now linear velocity to calculate, you have to know your formula. Linear velocity is equal to r times angular velocity, and centripetal acceleration AC is equal to r omega square. So you need to know here the angular velocity. First of all, we'll find out the angular velocity. What is the formula for angular velocity? Then omega is equal to 2 pi nu. This is the formula. With that, we'll find out the angular velocity. Angular velocity, omega is equal to 2 pi, the linear frequency, and this is 2 pi. Linear frequency is 50 divided by 3 hertz. So you can write 50 into 2 is 100 by 3. 100 if you divide by 3, 3 3s are 9, 103, 3s are 9, 10, so it will be 3.33, it will go on. 3.33, pi keep as it is. Here the unit of angular velocity, SI unit of angular velocity will be radian per second. Hertz means per second, angle is in radian, so it will be radian per second. This will give you your angular velocity. First of all, we will find out the angular velocity, then we will find out linear velocity. Linear velocity, as you know the formula, is r omega. R, what is R? It is 0.2 meter, 0.2 meter. Angular velocity, it is 3.33 pi radian per second. So 2 3s are, sorry, it is 33.3. This is 33.3. 33.3. This is 33.3. So if you multiply 2 3s are 6, 2 3s are 6, 2 3s are 6, after decimal 2 digit will be 6.66 pi. Linear velocity is meter per second. You can use your SI unit. Then comes your centripetal acceleration. AC. Centripetal acceleration is given by r omega square. R, you know the value of r, that is 0.2 meter, and omega square. Now omega square, if you say then this value square, you have to do it. 33.3 pi square. It will be radian square per second square, radian square per second square. So calculate it. So here the value will be 2 to 1.7. If you round off to 2 digit, then it will be 7.8 radian square, or you can write radian square meter per second square. Like this you can calculate the centripetal acceleration. This is the end of the chapter. Thank you and have a nice day. Stay tuned with LFI Educates.